Hello everyone, welcome to this video. In this video, we'll be seeing a method to determine all the homomorphisms given two cyclic groups from the first cyclic group to the second cyclic group. So here we are given the problem to determine all homomorphisms starting from the group Z12 to the group Z30, right? So first of all, you should note that these two groups, they are cyclic in nature. Right, they are cyclic. Why? Because the whole group could be generated by the member 1, because you can add here. What is the group operation for the first group Z12? You know, the element starts from 0 and go up to 11, and the group operation is addition modulo 12. And for Z30, you can see here that the elements start from 0 to 29 and the group operation is addition modulo 30. So in this case, the group the generator is equal to 1. Right, so here the generator is 1. What does it mean? It means that by adding 1 to itself, you can generate all the elements of these groups, right, like this. So this thing you know well, correct? And what is the order of this group Z12? The order of this group is actually 12, and the order of this group Z30 is 30. Why? Because it contains 12 elements within it and the second group contains 30 elements within it. Okay, so once you know all about these two groups, now we have to define a mapping from this group Z12 to Z30, and we have to define all the possible homomorphisms from these two groups, correct? Okay, so let's start. We know this group that whenever we have phi from the first group G to the second group G bar, if this is a group homomorphism with the group operation as multiplication, right? This is the group operation that we are always taking. Then in that case, phi into G into G into G itself, how many times? N times, right? This is equal to saying that phi of G into itself, how many times? N times. So basically this is the operation preserving property which is shown by homomorphism, right? So making use of this property, if you define the member 1 to go to A, right, under phi, so that means we are saying phi of 1 is equal to A, then by it, what does it mean? It means that you can also define it like this: 1 into 1 into 1. Here the operation is not multiplication, here the operation is this addition, correct? So it would be equal to phi of 1, which is plus phi of 1 plus phi of 1 up to so on. And if we are defining it x times, so here also we are defining it x times. So what is phi of 1? It is actually a plus a up to how many times? X times, correct? So it would be equal to what? It would be equal to xa, correct? So that means if you are defining a map going from 1 to A, you are defining it the same to be going taking this x to xa in Z30, right? So basically if you are able to know what is this A, you are able to know this mapping quite easily, and that will lead you to all the homomorphisms, correct? So that is what I have written here. If you are able to determine A, then you are able to determine all the homomorphic mappings from the group Z12 to Z30, right? Okay, so by the Lagrange's theorem, you know, for a cyclic group, the order of element divides the order of the group, right? So in that case, element A, because now if we are defining phi from Z12 to Z30, so obviously phi of 1 is equal to A, then this A would be present in Z30. So we are to determine what is this A, correct? So we are because we know Z30 is cyclic in nature, therefore any element A belonging to it its order would divide the order of the group, right, which is 30. So let's mark this as our equation 1. Now moreover, we know this property that whenever we have the order of G as finite number, right, then its the order of its homomorphic image also divides the order of the element. So here we know that the element 1 is present in Z12. So phi of 1 would be present where? In Z30, correct? Because that is our homomorphism. That is how we are defining the mapping. Hence, phi of 1 would divide the order of 1, correct? And what is the order of 1? Order of 1, because it is a cyclic group and it is the generator, so it is equal to the order of the group, which is Z12, and order of this group is 12, that you know. So that means phi of 1 should definitely divide 12, right? And what is phi of 1? It was A, because this is how we have defined our mapping, correct? So therefore in this case we have the order of A divides 12. Let's mark this as equation 2. So from equation 1 and from equation 2 we can clearly see here that the order of A should divide both 12 and 30. So what possible numbers can you get from here? We could get 1, 2, 3 or 6 when we have this condition that the order of the element A should divide both 12 and 30. So therefore in this case, what is the element A? We know the order of this as 1, 2, 3 and 6. So which possibilities are present here for A in Z30? So we know the members present in Z30, they are 1 to 29, right? So if the order of A is 1, that means A has to be 0, correct? If the order of A is 2, then A has to be 15. Why? Because when you do 15 plus 15, you get 30, and 30 mod 30 is equal to 0, right? Which is the identity of the group Z30. So therefore the order of the element 15 is 2, hence you have A is equal to 15 in this case, and there is no other element within Z30 having order 2. Similarly, the order of element, if it is 3, then the elements are 10 and 20. Why? Because when you add 10 3 times, you get 30, and 30 mod 30 is 0. And when you have 20 added to itself 3 times, it is 60, and it is equal to 0 mod 30. So therefore both the orders, they are equal to 3 in this case for 10 and 20. Why? Because you do not have a lower order such that it gives you the identity 0, correct? If we have the order of element as 6, then the possible elements are 5 and 25 out of these 30 elements. Why? Because when you add 5 to itself 6 times, you have 30, which is 0 under mod 30. And when you add 25 to itself 6 times, you get 150, and 150 mod 30. When you divide 150 with 30, correct, you have 0 as the remainder. Hence you obtain the identity here in this particular case, correct? And for no other value lower than the value 6, you get 0. Hence 6 is the order. Therefore we have obtained 6 numbers here such that their orders are either 1, 2, 3 or 6. So therefore these are the 6 possible values of A. Once you know the values of A, you already know what are these homomorphisms. So I have written all the homomorphisms like this. Our first homomorphism is defined like this: phi of x is 0. The second, because we have defined our homomorphism phi from x to ax. Now once you know the value of A, so your homomorphisms becomes like this: phi of x is 5x, phi of x is 10x, phi of x is 15x, phi of x is 20x and 25x. And moreover, each one of these phi here is operation preserving and well defined. You can check it by yourself. That is a very simple exercise, right? And moreover, the GCD of these two numbers, and if you notice that our first group was Z12 and the second group was Z30. So if you notice that the GCD of 12 with 30, it comes out to be 6, and in overall we are getting 6 homomorphisms with us. So I hope you understood this problem well. Well, that is it for this video. Thank you for watching.